thank you very much. So for those of you that have worked with Argo CD or Flux CD, you have definitely seen this problem before. Someone opens up a pull request where they make a few changes to a Helm chart or some customized template, but the problem is that you as a reviewer have no idea how these changes impact the system. And that's because you're not getting a full preview here. You're not seeing the full picture, and mentally rendering Helm charts and customized templates is kind of impossible. So what we want is instead some kind of preview that can show us what will the final result be of these templates and customized builds here before Argo CD or Flux applies them to the cluster. And this concept is something we already know from Terraform, where we can write Terraform plan, and then we get an output describing what resources are being modified. And this is something we would like in the GitOps Kubernetes world as well. So for Argo CD, there's two tools to try to do this, and one is called Argo CD Diff Action, and other one is called kubechecks. So if you find this topic interesting, I think you should definitely check these out. But as I see it, there's two main limitations, and the first one comes from security. And that's because these tools need direct access into your live Argo CD instance that runs inside your cluster. Some companies may consider this a security risk, so keep this in mind, and that's the first limitation. The second limitation is related to this concept of correctness. So the way these tools work when they figure out what have changed on your pull request is that they look what exists inside the pull request you just opened and compares it directly to whatever exists inside your cluster. But the problem here is that the state of our clusters changes all the time. Different operators create and delete new resources all the time, meaning that the output these tools are producing is not deterministic, and I think that's a problem because we prefer reliability when we do these infrastructure updates. But fear not, I have a solution for you, and that is that we start using ephemeral Kubernetes clusters to render these manifest changes for us. So think about it this way: how can we use a tool like Kind or Minikube to figure out what have changed between two branches without accessing any of your live infrastructure and doing the whole rendering process locally using a local version of Argo CD? This enables us to build a system that looks like this, where some developer can open up a pull request where they make changes to Helm chart or customized template. And the first thing that happens is that we trigger an automated pipeline. And inside the pipeline, we install a local Kubernetes cluster that is only accessible inside the pipeline. Then we install Argo CD on top of it and apply all our applications from both the main branch and the pull request branch, apply them to the cluster, let Argo CD do its rendering magic, and then we can extract it out later and do a git diff at the end to show exactly what have changed on the pull request. And don't worry, I know this is a bit technical here, but the good thing is you don't have to go home and build this stuff yourself in Bash like I did originally, because I created an open source project for it called Argo CD Diff Preview, which pretty much just encapsulates this logic for us so it's easier to work with. And it creates a beautiful comment like this on your pull request explaining exactly what have changed in the rendered output between the two branches, making code reviews much easier. The good thing is it's very easy to set up. All you need to do is copy-paste a few lines from the documentation into your own repository, and you should be good to go. So what did we learn? This is a short talk. We learned that using ephemeral Kubernetes cluster to do our rendering of our manifest changes is more secure than other alternatives because this runs in complete isolation, not touching any of your live infrastructure. And I would argue that the result we're getting is much more correct and reliable than the other alternatives out there because we're only looking at whatever exists inside Git, meaning that as long as there's no dependency changes, this output is deterministic, and that is kind of great when we want to do infrastructure updates. The main limitation is, which I've not mentioned so far, is that this process of starting an ephemeral cluster is of course a bit slow because you need to spin up the cluster and install Argo CD on every single pull request. That step alone takes around 70 seconds, but hopefully you can survive that. That is the main limitation of this method. I did a 25-minute talk about this last week at ArgoCon in the US together with the Argo CD maintainer. So if you're interested in this topic, I think you should definitely check out the full talk. And most importantly, if you have a better solution to this problem, please come talk to me because I would love to hear it. Thank you very much.